Guys, so we will continue where we left off yesterday. Yesterday we configured the serials as the last configurations that we made. Today we're going to start off with floating static routes from the ISP server, ISP router to our network routers. So basically, um, our two routers here that are inside of our network. They're going to be using OSPF basically to allow uh, our connections to the ISP to be able to talk to VLAN 10 and VLAN 20, basically for outside network connectivity. Um, and we'll also use static routes, specifically floating static routes. Floating static routes basically just static route with a modified administrative distance, so that OSPF takes priority. Um, because if I was to configure OSPF and then a static route would take priority, and we don't want that. We want to use our dynamic routing protocol if able. And if that fails, we don't want to lose connectivity altogether. The floating static route is the backup. So let's go ahead and configure the floating static route. Um, so for the routes that we need, we are going to need two going this way, two going that way. Okay, so I'm going to say let me exit out of the configure interface mode. I'm going to say IP route to configure a static route. And we want to specify where do we want to go. And we know, here's the information here, but we know this is 192.168.1.0, so that's VLAN 10, and 192.168.2.0, which is VLAN 20. So that's the locations where we're going to go. 68.1.0. And we also need to include the subnet mask of that network. And we want to specify the next hop. So if going this way, the next hop is going to be 10.10.10.1. Next hop is the next router it jumps to, the next router interface. So it's going to be router one's serial connection here. So say 10.10.10.1, and we don't have to specify the subnet mask. Oh man, wait a minute, I want to say no because I did not modify the 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 administrative distance. So after I have, okay, easy fix. After I have my IP route, I push question mark, and this is what we want to. This is basically administrative distance. Like, what would you like it to be? With OSPF, which is going to be the routing, dynamic routing protocol that we're going to configure on this network, its administrative distance is 110. And the way IP routing works is the lower the number for administrative distance. So let's say if this number is one, which is what static routes default to, um, the more of a priority it will use. So that means if I did not adjust this administrative distance, I would configure OSPF and then basically it would become the backup with static routing taking priority. I don't really, that's not what I was really going for. So I know the administrative distance of OSPF is 110. I'll just make this 140. Boom. Okay. And now I'm going to do the same thing, but for um, VLAN 20. So the only change is to this octet here. It's going to be a 2 instead of a 1. And we're going the same way. So 140. Okay. And now I'm going to push up arrow again. Actually, this one might be better just to write it out. Oh, no, this one. So let's do the same thing. So this time I'm going to go this way, and we're specifying VLAN 20, but I gotta, since I'm going this way, this IP address is 10.10.20.1. So I'm just going to edit this a little bit. There we go. Um, and I can also change this up a little bit. So this would be the less preferred route. Oh well, default on this. If hmm. So this is the HSRP uh prioritized standby route for VLAN 10. This is gonna be the prioritized VLAN for VLAN 20. So let's make this one for VLAN 20 120. Because I want to make it so these floating static routes, if they're getting utilized, to utilize the more efficient route, which is going to be the one that is going to be configured with the primary spanning tree route path, as well as HSRP, whatever we configured that one as far as like this one's taken preempt and has a higher priority with HSRP for VLAN 20 than this one does. So, all right. And with uh, network VLAN 10, we want to do the same thing, except this one will be, let's just say 150. So those are our four routes. And we can just make sure they work by testing our um, PCs that we gate static IPs to. By the way, those static IPs, we're going to change to DHCP once we set the DHCP server up. Servers, I guess, I have to say. All right, so if I say do show IP route, you will see we typed in four routes, but there was only, so the S is short for, if you look at codes for static, you only see two, and that's because the IP routing table only shows if there's multiple connections to the same network, it only shows uh, the connections that take priority. So these are our two prioritized floating static routes. And with VLAN VLAN 20, which is 192.168.2.0, it has an administrative distance of 120, and it's going to go this way to work in conjunction with HSRP and later on spanning tree. And for VLAN 10, 192.168.1.0, has a floating static route of 140. It's going to go this way instead to do the same thing, work in conjunction with HSRP, and later when we set up spanning tree protocol. All right, so do right. Well, actually, let's say do in 192.168.1.1. It should work. There we go. And what about to VLAN 20? That's a work of those things. That's okay. I'll see. What did I configure this PC as? Config. Oh, well, that's. Did I configure any of these with the default gateway? Okay, 250. Okay, I didn't edit the default gateway for this. So what is the default gateway? I can't remember. I think it's 254. 250. Is that one, two? Let me just double check something. Global. That should work. Uh, Just check something. Do ping 192.168.2.25. So that's 2.1. Okay, so that works. Search for here. Should work. It's using HSRP. If HSRP is working correctly, it should work. Yeah, it works fine. So I wonder why this timed out. So since that's timing out, I'm gonna check my IP route as well as my connections here. So what is the show IP interface? Brief? This will tell me what I already know. Oh, so 0/3/0 is outpop. Okay, good. 10/10/21. That's what we want. Show this one. To show IP interface. 0/31. 10/10/1. Perfect. 192.168.2. 50/50. Perfect. Interface. Interface. 3. I'm gonna check something else. I'm gonna check standby. To show. You'll be able to see here. Okay, that's the problem. I never configured my default gateways to standby. So let me change all this. This is before. Sorry guys, it was late last night when I was doing this originally. I forgot which ones. Now I should be good. Let me just make sure these work with events. Perfect. Perfect. So we know standby is good. I'm not gonna. Oh, it's better just to do the two-way connection for now. Because if there's a problem, it's easier to fix it now later. I'm sorry, outside. Two. Perfect. That's what we want. That's the ISP router. And the other way. Oh, whoops. Destination host unreachable. That's okay. That's something to fix. Desktop. And from 20.10.2. Perfect. Okay. 10.10.10.2. The reason it's given us this is because of floating static routes that we set up. They're prioritized to go either this way or that way. This way for VLAN 10 and this way for VLAN 20. But when I set up OSPF, they should be able to take either route. Okay, so before we can do OSPF now. So OSPF is really easy. Oh, by the way, these are going to be the only two routers participating in OSPF. We're going to just assume that this is the internet service provider and they're going to be using like their own routing, dynamic routing protocol. probably like BGP or something like that. All right, so for um, for OSPF, we're going to say router. We can push question mark, and here are our dynamic routing protocols. We're going to use OSPF question mark. We use one as a process ID, and then boom, and then you can see our configuration changes to configuration router. Then we can push question mark to see our choices. I'm gonna make a manual router IDs because I didn't assign any loopbacks. Router ID. We'll make this 1111 and the other one 2222 since it's router one, router two, respectively. Uh, and I'm also gonna say router. Uh, Oops. Is it passive? It's been a minute since I've done this. I want to make serial 030 a passive interface just because I don't want it to send any messages via OSPF that way. Just because that router is not using OSPF. Well, we're on the assumption that won't. But so serial, and we'll say 03/1. Now we could, so with OSPF, setting up OSPF on a serial link's a little bit different. You have to set up as a point-to-point connection. It's pretty easy once I'll have to show in another video. But for this purpose, we're just going to use router one, router two. And network is going to allow me to basically advertise networks that we want to use. So I want to advertise, I want to let VLAN 10 and VLAN 20 know, hey, there's a path here. It's going to be, you know, 10.10.10.0 and a slash it. Now it is a slash 30, right? But OSPF uses wildcard. So for example, typically the subnet mask will look like this. It's going to be completely flipped. So instead of 255.255.255.252, it's going to be the complete opposite. So it's going to be 0, 0, 0, and the remaining three. It's very weird at first, but like that. And then we want to set the area. All these are going to be area one. Well, I'm not gonna all of these. Both routers, area one, just to make it easy. All right. And then I also want to say network. The other network that's connected here is 192.168.1.0 because that's going to be VLAN 10. And now its subnet is usually this, right? But since it's wildcard, it's going to be actually the 0, 0, 0, 255. So 0, 0, 0, 255 area 1. And then I'm going to do it one more time for VLAN 20's network. Guys, I'm going to probably split this video just because my laptop is about to die. 255, area 1. The area has to stay the same or the OSPF advertisements will reach each other. And neighbor adjacencies between router 1 and router 2 will not form. So that looks good. And that's all we do for OSPF on this side. It will not, if I look up the logs, it will have no neighbors because this one is not set up for OSPF yet. So let's go ahead. Oh, by the way, when I configure these as IP routes, you won't see it yet until they form adjacencies. Okay, so IP routes. Oh, sorry. Um, router OSPF 1. We're going to say passive interface serial 030. Okay, because I don't want that advertising OSPF over the zero connection. And then I'm going to do the same thing. I'm going to say router ID, and this one's going to be 2.2.2.2. And then I'm going to say, I'm going to include my networks. So this one's going to have 10.10.20.0.0003 area 1. Then I'm going to include also VLAN 10 and VLAN 2. 0.0.0.255, 1, 2.16.2.0. Whoops. There it goes. That's basically saying neighbor adjacency is formed. Oh man, what was it doing? Sorry, that just sucks me right out of my train of thought when that happens. 2.0. There we go. And as I was typing that, I just realized something. I set up floating static routes, and my network configuration is not going to work as I have had intended it without this taking OSPF. Um, yeah, I'm gonna probably set up OSPF with this one as well, just because even if, well, I'm gonna test it out. Maybe I'm overthinking it, but I got OSPF set up here, and I want that if this router goes down, even though this is the prioritized router of VLAN 10, that it will still use this route. But let me check. I'm just having my brain's not braining right now. I know I've set up floating static routes, so right now, well, before OSPF, I think even with OSPF, since this is not receiving OSPF traffic, um, if this one goes down, VLAN 10, previously with the static routes, it was unreachable if it went the other way. Uh, we're gonna test that out later, just to make sure it's working as intended. All right, so now let's do step 5. I know I have spanning tree up here, but it's pretty easy to set up. Let's get the HCP split core. Now, split core architecture is basically a very um complex way of saying we're gonna put some of the DHCP network pool on this router and some on this router because Cisco Packet Tracer doesn't. Let me see how charge this is. 19%. Just a plug in real quick. Cisco Packet Tracer doesn't really, as far as I know, doesn't support any way for it doesn't support any method of redundancy. DHCP. Wait one second. Okay, perfect. All right, so let's go ahead and do DHCP now. Uh, or maybe I should I'll do spanning tree last. Okay, good. This is what we want to see. It's formed a full neighbor adjacency. And if I wanted to double check, actually, do you show run? Actually, I don't know if this is gonna show me that or not. I'm not gonna see. Oh, well, will show me the OSPF information. So doesn't the wildcard look weird? Hmm. All right. Oh, passive interface. That's just the interface it's not going to. Um. Oh, if you wanted to see your do show IP OSPF neighbor, you can see we have 4 adjacency. Uh, Now it shows the same router twice as a neighbor adjacency because there's actually two routes to that router. Well, using my sub interfaces here. So, not two routes, but two interfaces. But and then if I typed in, oh, so do show some of the commands on Cisco Packet Tracer are very um, temperamental. If I were to make this a S, it will fail. But if I take the S off, it shows me that router 2 has formed a full adjacency. All right, so enough of that. Um, what we're gonna do now is set up DHCP. So let's get out of router configuration mode. We'll say, I can't remember if this is interface specific. Okay, no, it's not. Perfect. All right, so for router 1, it's gonna, so, how will we do this? So router 1, I'm gonna say excluded address, and we'll say 192.168.1.0, and then it's basically specifying a range of oh, not one, zero, sorry, of 1 to 192.168. Let me change this. 50 192.168.1 dot 100 question mark. Well, you know what? We'll do 254. Okay, I'll show you why in a minute. We don't want any the we don't want DHCP to configure anything like 254 because that's actually HSRP virtual IP, and that would not be good if it configured PC with that. But I'll show you why I did this in a minute. It's gonna look weird right now. So this DHCP server, once it's set up, is only going to be able to configure uh, IPs 1 through 49. All right, let's see what else we can do with IP DHCP. Cool. And then we can say, okay, this is a blue. So that's what it is. Question mark, and I get carriage return on some backspace. And this is where we can actually configure DHCP. Network is going to be 192.168.1.0. Oops. And question mark, we do need the subnet mask. So I'm not doing wildcard. That's just for um, a specific uh, routing protocol. All right. Question mark again. This option we're not going to use. There's a few different options. One of them can be for setting up uh, wireless devices, stuff like that. I don't need domain name or DNS server just because with that, uh, it's I don't have a DNS server set up, so there's no point in using those. But if I did have a DNS server, this would help point my devices to that server. So that's actually a very helpful thing for DHCP. I will set the default router, and it's going to be our gateway, so our SRP route. I think that's all I need to do for that. Just double check IP DHCP. Sorry, it's been a minute since I've used this. IP DHCP. I don't need it. I don't need it. Okay, that's all. So that's all. VLAN 10 is set up. Now, I also want to do I want VLAN 10 to have, with split core architecture, I'm using both of these to do basically the same thing, but I'm excluding addresses on purpose. Uh, that way, um, that way, if one of these DHCP servers go down, DHCP is still going to my VLAN and providing dynamic addresses, IP addresses. So we're going to do the same thing. We're going to configure VLAN 10 first, and then we're going to go back to this router and do DHCP there for VLAN 20. So exit out of this, IP DHCP excluded. So we want to exclude 192.168.1.0 50. Okay, let me just double check something real quick. Which ones did I exclude on this route? I guess a pen and paper would have helped. Okay, we excluded 50 to 254. So on this one, we want to do the opposite. We want to exclude 1 to 192.168.1.49. So we don't get any of those. But I also have to include, like, I don't know, 250 to, because I don't want this to use my network devices. And this is a really small number. Realistically, if this is a real network, I would have to adjust this. We would have more than 4 IPs for our network devices. Actually, let's go ahead and do that because that's too small. Especially if you, when you're like, if this business expands or whatever, that's just not enough. I don't think it should get 255. I can't remember if DHCP will actually. I don't think it takes that. This is the forecast. There we go. So I'll say IP DHCP just in case. Okay. Oh yeah. Okay. I do one more thing. I'll say pool question mark blue. I think I can use the same. All right. And now we have to configure the network that we want. So 192.168.1 dot 0 2 5 5 2 5 2 5 5 0. And then we want to tell the DHCP server what's our default gateway for that. 192.168.1.254. Do right. All right. So DHCP is set up split core architecture wise for VLAN 10. Now we're going to go back and do the same thing for VLAN 20. Yeah, split core is just a fancy term for saying those. It makes DHCP redundant. All right, so for this one, we see IPDHCP question mark excluded address. Uh, we're gonna flip flop. I guess it doesn't matter in this scenario. No, we're gonna make this 1 through 50 for both of them. I'm sorry. You know what I mean. IP DHCP excluded address 192.168.2.50. Oops, jeez. And through 192.168.2.254. All right. IP DHCP, and then I'll type pool, yellow. What network do I want? One, I actually let me question mark that. Okay, good. 0, 255, 255, 255, 0. And I also want to say, I want to specify the default router, which is also another word for the default gateway. And it's going to be our HSRP virtual IP. Perfect. So that's all we have to do here because I don't have anything like DNS or anything like that set up. Okay, we'll do the same thing on this one. IP DHCP excluded address. Oh, I thought that was going to autofill this time. I'm a trip or something. You did that. Unrecognized. What did I do wrong? Oh, okay. It's already in DC configuration mode. Sorry about that, guys. Tab. And we want to exclude this time. Let's say 1, 2. Just double check. Which ones did I exclude last time? 1 to 49. So this time we'll exclude 50 to 192. 68 top 2. Whoa, I messed up. 2.50. Okay, I'm mixing this up, guys. I'm gonna have to use a pen and paper next to do this. Which one did I exclude on this one? Where's blue? Where's yellow? Okay, yellow, good. Okay, 50 through 254. Okay. So this one, I don't want to exclude those. I'm going to exclude one, two, 192.168, then one dot, whoops, 2.49. And I also want to add the network devices too. Don't forget those, or sometimes the HTTP might try to use one of those IP addresses. But yeah, I want to exclude 205.5 because I don't think it would actually try to use one of those. I'm not going to exclude that. I'm sorry. All right. Now I also want to say IP DHCP pool, and it's going to be yellow. And then I'm going to specify the network 192.168.2.0, 2.5.2.2.5.0. And I want to include the default gateway, 192.168.2. 192.168.2. Oh, sorry, guys. Right. All right. So in theory, that should work now as intended. Um, let's just double check. So this one was previously static. Swap it to DHCP. Perfect. What? Okay, so we got default IPv4 address. So 192.168.1.50. Perfect. That is what we're looking for. And with this one, instead of pushing the DHCP button, I could go on desktop, ipconfig. Okay, we have nothing. ipconfig / renew, and that's going to basically tell DHCP help. It sends us out an address. Perfect. That's what we want. Default gateway is right. Good. DNS server 0000 because I don't have anything set up. If I did want to add a DNS server in the future, I wouldn't want to configure all these manually. I could just go back into the DHCP server menu, commands, and type in my DNS server, and it will configure all these with that DNS server. Let's just make sure this one works as well. This is the side. So for the first one, we'll see DHCP. Perfect. That's what we want. Make sure it doesn't say one on there. Perfect. And again, command prompt ipconfig. Okay, good. Everything's 0. ipconfig. Let's say help to the DHCP server. Perfect. By the way, guys, if I were to have configured this DHCP server, say for example here, then this would be outside of our connected network here. I would have to configure this interface. Well, one of these interfaces, oh, I guess these interfaces as IP helpers to basically tell, uh, hey, VLAN 10 and VLAN 20, we're getting out DHCP uh, information from outside of the network. It's over here. But since these are both connected to VLAN 10 and 20 pretty locally, we don't have to do that. And that would be configured right on the interface. All right, so last but not least, we will configure uh, spanning tree protocol. And I'm actually probably going to cut this video off because it's already 39 minutes into it. I don't know if it's a good idea to do spanning tree last. It probably should have been done earlier. But what we're going to focus on is basically there's some links that take too long to aggregate, for example, network to network device and so forth. We also we want to make that so there's no they turn on automatically, like ASAP. And we also want to say, let's say this is VLAN 10's HSRP priority or prioritized route. We want to make sure that the traffic is going in the most efficient route. And I'm not going to mess with spanning tree costs or anything like that. This is just going to be more so the preferred, like we're gonna make one of these spanning tree primaries route pass for VLAN 10 and one of these for VLAN 20. Actually, we can go into it now. It don't take that long. So this one, so VLAN 10 prefers this route. So what we'll do, actually, let's do this in the next video.